Let's continue on chapter 6 on normal probability distribution. You can also simplify this with a normal distribution. And this section, I'm going to concentrate on the non-standard normal distribution. Because standard normal distribution is a special case of normal distribution. Because the mu equals 0, standard deviation equals 1. So now we're going to deal with those normal distribution with the mean is not 0 and the standard deviation is not 1 or both. So the key thing here is we're going to use a simple conversion that allows us to standardize any normal distribution so that the same method of the previous section could be used. So now we use the conversion formula z-score equal to x minus mu over sigma. So here x represents a continuous random variable. Mu represents population mean. And sigma represents population standard deviation. Okay, and now sometimes we may have to convert in the we're given a probability. So if you're going backwards to find the x value, you're gonna do this using if you're really given probability, you want to go back to the x value. So using this conversion, x minus mu is the proportion, so we cross multiplying equal to z times sigma. So adding mu from both side equation, we get x equal to mu plus z times sigma. So if you're given the probability, you can go backwards, find the continuous random variable, the value for that particular continuous random variable. Just one more thing is run the z-score to 2 decimal places. It's like the convention. And so giving any normal distribution, we're typically talking about a non-standard normal distribution. You basically just convert it using z-score formula to convert it to standard normal distribution, and then from there we'll be able to find out the probability according to table A2. So we use the z-score formula to convert it to standard normal distribution. Procedure to find the area with the non-standard normal distribution. First of all, sketch a normal curve. You can also call that bell curve. Label the mean and any specific x values. A shaded region represents the desired probability, which relevant x value as a boundary for the shaded region. Using z-score formula 6-2 is a z-score formula. To convert that value to the equivalent z-score. So z-score is like the tool or bridge connecting a continuous random variable with the probability. You can also use computer software calculator or table A2 to find the area of this shaded region. So the area is the desired probability. So let's take a look at example. Tall Clubs International. Tall Clubs International has a requirement that women must be at least 70 inches tall. Given that women has normally distributed heights with a mean of 63, so we're talking about population mean mu equal to 63.8 inches. Standard deviation, population standard deviation 2.6 inches. Find the percentage of women who satisfy the height requirement. So again, you draw the bell curve. The mean goes in the middle, mu equal to 63.8. And the x value, x must be greater equal to 70 inches. Okay. So right here, 70 inches. It's on the right hand side of the 63.8, on the right hand side of the mean, and we are looking for the area to the right, because at least, right, that indicates we're looking for the area to the right. And so here we basically need to convert it. We draw the bell curve already. So now we need to find out the standardized z-score using the z-score formula. And again, we're looking for the error to the right. So using the z-score formula, so z-score formula equal to x minus mu over sigma. Then we convert it to the z-score, standardized z-score. So now apply the formula. Z-score in this case should be x equals 70 minus 63.8 dividing by 2.6. And keep it, run the answer to 2 decimal places. 70 minus 63.8 divided by 2.6. Then that turned out to be 2.38. So the z-score is approximately equal to 2.38. Now standardize this, z-score equal to 0. So the standard normal curve and then right here the z-score is equal to 2.38. Now this height is turned into a standardized z-score. So that means this height is 2.38 standard deviation above the mean. And from there we'll be able to find out the probability associated with this height. Again, convert z-score formula 70 minus 63.8 by 2.6 approximately 2.38. Now go back to the table A2. So click on table A2, look for 2.38 on the second page of the z-score formula. On the second page of table A2, you're going to see 2.38. You're going to have an intercept right here. As you can see, the probability associated with the z-score of 2.38 is 0.9913. And that indicates area to left hand side, right? So again, this table only gives us area to left hand side. Now if we go back, since we know the area to left hand side is equal to 0.9913. Then we can use that to find the area to the right, and that's what we're looking for. Now on the left is 0.9913. However, we're looking for the area to the right, so total probability here is 1 minus area to the left. So the probability for the height is greater or equal to 70 inches. Be equal to 1 minus area to left 0.9913 and turn out to be 0.0087. If you turn into probability, it will be 0.87%. Okay. And also you can find this probability in the in Excel. I'm going to show you how to do that in Excel. You open Excel. So here we know x equal to 70, mu equal to 63.8, and standard deviation sigma equal to 2.6. I'll find a sigma right here, okay, equal to 2.6. Now once you have those three numbers, and then you can just put in the formula means normal distribution, DIST, open parentheses, put in x value 70, in this case the height is 70, and standard deviation, the mean is 63.8. Standard deviation, put in standard deviation 2.6. Yes, we are accumulating everything to the left, so putting true. Now you can easily just find the probability, which is area to the left. So if you want an area to the right, this is area to the left. So area to the right is equal to 1 minus previous. Okay, now this turned out to be 0.008548. So again, in Excel you can get an answer with much more accuracy, but it's approximately same result. Also, so area to the right. Also, if you're using this, since the z-score we calculating equal to 2.38. So now we're gonna do standard. So now that the standard normal distribution, we are putting the z-score here 2.38 as we run it. Put it true, and you should see the exact same answer, 0.9913, right? If you run it to 4 decimal places, as a table shows. Table shows 0.9913. Let me just reduce to 2 decimal. Because due to rounding, so here we are using exact same result to get a probability. Due to rounding presented in the question, we run to 2 decimal places, so the area to the left turned out to be slightly different due to rounding. So the area to the right will be equal to 1 minus previous one, 0.0087, which is exactly the same thing as what we have. That's what we just calculated. So if you want more accurate answers, do not run it, and you can use Excel to get more accurate answers. But if you run it, you're gonna get the best possible estimate, right, from the table A2, based on table A2. Okay, so let's go back to the PowerPoint. Let's wrap up the rest of the stuff. Okay, so we find the probability so that only out of 10,000 women, only 87 will meet the requirement. That's what this 0.87% indicates. So it's a very low probability. It's highly unlikely. Okay. And sometimes we may have to go backwards. If you know the probability, then we need to find out the corresponding x values for a known area. That's what this means. So going backwards, we need to find the x values equal to mu plus z times sigma. Right? We all just derived the formula from earlier slide. So first of all, don't confuse z-score and the area. Z-score is used to find the area, but they are not the same. Also choose the correct side of the graph, meaning you need to label the area correctly. That's important. Sometimes you're looking for the area to the left. Sometimes you're looking for the area to the right. Sometimes you're looking for the area in between. And the z-score must be negative whenever it's located to the left half of the normal distribution. It's positive when you locate it to the right half of the normal distribution. Area are positive or zero, because we're talking about the probability. Area is a probability, so they are never negative. So now let's look at the procedure for finding values for no area of probability. So in this case, we do know the probability, and we're going backwards to find out the x value corresponding to that area. First of all, sketch the bell curve. Enter the given probability, the percentage in the appropriate region of the graph. Identify the x values being sought. And if using technology, refer to the instruction at the end of the text, section 6.3, using table A2. And you can definitely use the table A2, or you can also use the Excel. So basically, you refer to the body of the table A2, finding the closest area, then identify the corresponding z-score. So look back into the center of the table A2 and find out the corresponding z-score. Then we use the formula 6-2. You could do a little conversion to get the x value by itself using some algebra. And given mean, population, standard deviation, z-score, and we find out the x values, which is what we call a continuous random variable, mu plus z times sigma. Then refer to the sketch of the graph to verify the solution makes sense to satisfy this particular context. And let's take a look at the example on the aircraft cabins. We're designing aircraft cabins with ceiling height to allow 95% of men to stand without bumping their heads. Men's heights are normally distributed with a mean of 69.5 inches, standard deviation of 2.4. So here mu is given equal to 69.5 and standard deviation equal to 2.4. Now, first of all, you draw the bell curve. You try to separate the bottom 95% from top 5%. Total is 100%. So according to that, let's find out the z-score here. Okay, so again, 95%, 0.95. So you go to the center of the table A2, look for the z-score corresponds with the 0.95, area of 0.95. Again, go to table A2, 0.95. We already did it earlier, and this turned out to be 1.645. If you follow the direction arrow down there, the corresponding z-score is 1.645. And let's go back here. Z-score is turned out to be 1.645. Now if you know the z-score, now we can use a formula. Okay, so now we know z-score, we know mu equals 69.5, standard deviation equals 2.4. Again, you can just plug into a z-score formula, x minus mu over sigma. Okay, z-score is 1.645. X value, that's what we're looking for, mu is 69.5 divided by 2.4. Alright, so now cross multiplying, you can get x minus 69.5 equal to 1.645 times 2.4. Then you're adding 69.5 from both sides of the equation, you get a result. Cancel that x, which is the cutoff height to separate in the bottom 95% from top 5%. 69.5, adding 1.645 times 2.4. That turned out to be 73.448 inches. And this is cutoff height to separate in the bottom 95% from top 5%. So, meaning if the man's height is below 73.448 inches, he will fit in the aircraft cabins. Okay. Application of normal distribution. First start, you want to find the probability for known value of the x, either using the Excel or table A2, or using to find the probability. You want to find the value of the x from a given area of probability, and then find the probability using the. So this is explaining if you're using table A2 to find out the probability, using z-score formula, find the z-score, and look up the z-score in table A2, and find the cumulative area to the left. You can also use Excel or any technology software, find the probability using technology. So if you are using the area to find out the corresponding x values, first we look up the cumulative area, left area in table A2, find the corresponding z-score, and solve for x using the formula. We can find x directly from the technology. Again, I'm going to show you how to find this, the height in Excel right here, given this information. Again, let me open Excel. So here we are given the z-score equal 1.645. Okay, we know the mu equal to 69.5, and the standard deviation is 2.4. sigma equal to 2.4. Now use this formula. So in Excel, in order to insert a formula, put equal sign non dot inverse, meaning inverse of normal distribution. It's exactly inverse process. This means in this inverse, you put in the probability, mean and standard deviation. We know the probability, which area to the left is 0.95. The mean is 69.5. Standard deviation is 2.4. And the Excel will automatically give you the result, 73.446. No, 448. It's 73.448. If you run it 3 decimal places, it will be the same result. Okay. And this formula gives us the inverse of the normal distribution. And that's pretty much it.